We will now investigate factoring trinomials that have a leading coefficient other than 1. So a trinomial with a leading coefficient other than 1 may look something like this, where you can see our leading term is 3x squared. To factor these trinomials, we could guess and check. However, I prefer a more methodical way. So I begin by multiplying the leading coefficient, 3, by the constant, 8. I'm next going to list all the pairs of numbers that multiply to equal that product, 24. Now that we have multiplied 3 times 8 to equal 24, we need to look for the pair of factors that add up to our middle term of 14x, and that would be 2 times 12. Now, we are now going to rewrite this middle term of 14x as the sum, or sometimes the difference, of the two factors of 2 times 12. So rewriting that, we have 3x squared plus 2x plus 12x plus 8. Notice all I have done is rewritten that middle term of 14x as 2x plus 12x, the factors I found. I have not changed this problem. However, when I see 4 terms, I'm going to think factor by grouping. So, with these 4 terms now, and notice in this instance I've written it as 12x plus 2x. It doesn't matter which way you would write these middle terms, we're still going to be able to factor by grouping, as nothing has changed from the original trinomial. So, 3x squared plus 12x plus 2x plus 8. I group my first 2 terms and my second 2 terms. I factor out the greatest common factor, 3x, leaving x plus 4, plus 2 times x plus 4, and now write that as 2 binomials, 3x plus 2 times x plus 4. If I want to make sure that this set of binomials, 3x plus 2 times x plus 4, is our trinomial 3x squared plus 14x plus 8, I can FOIL or distribute to check. 3x times x is 3x squared. 3x times 4 is plus 12x plus 2x, and 2 times 4 is plus 8. Notice those middle terms of plus 12x and 2x. Now combine to 3x squared plus 14x plus 8. It's important to always look to factor out the greatest common factor first, and in this trinomial I have a greatest common factor of 3x. After taking that, factoring that out of the trinomial, I am left with 2x squared plus x minus 21. I need to continue factoring this trinomial, 2x squared plus x minus 21. So I'm going to multiply my leading coefficient of 2 times my constant of a negative 21 to get a negative 42. I'm looking for 2 numbers that multiply to a negative 42 but add to a positive x. So the difference between those has to be 1, and I see that 6 and 7 multiply to 42, and multiplying to a negative 42 but adding to 1 means that the 6 needs to be negative. So this 3x is going to stay out front, but I'm going to rewrite now my trinomial as 2x squared minus 6x plus 7x minus 21. Notice I have not changed that trinomial. 7x minus 6x is x. And now I want to continue by factor by grouping. So I'm going to group my first 2 terms and my second two terms. For my first two terms, I can take a 2x out, leaving x minus 3. And in my second terms, I can take a 7 out, leaving x minus 3, meaning this trinomial factors into 2x plus 7 times x minus 3. But what we can't forget each time is that greatest common factor, that GCF of 3x that we took out. So our final answer then would be 3x, that greatest common factor, times 2x plus 7 times x minus 3.